Okay, people are a little late. We've waited long enough. I'm Joe Gallant. I'm a senior product manager at InterSystems, responsible for our analytics, deep sea technology, as well as our SQL technology. But the focus for today is in analytics, part of analytics, the foundation of analytics is building a good data model. So we're going to talk about what that is. This sentence is sort of an amalgam of sentences of pieces I've heard from other people. What is analytics? People say, analytics is dashboards. And they're like, you all think of the end. Like, why are we doing this? You know, we're using data to provide, hopefully, meaningful insight to support, hopefully, well-informed decisions. The whole purpose of doing analytics is so you can run your business better, find out what's going on, and decide to do things based on that information. Dashboards happen to be one of the ways to present that information to you so you can do things. You know, with Deep Sea, the dashboards can also have actions so you can actually decide and call back to the app to do things. That's the end result. We had other sessions about dashboards. And by the way, all the sessions this week have been recorded, and the slides will be posted post-conference. You'll be getting an email as an attendee saying where they are. But while we tend to think of the end result, part of it, the key is really, where do you start? You know, to get good results, you need a good foundation, and a good data model is really the foundation of doing good analytics. If you don't have a good data model, you have pretty dashboards showing you meaningless information. So starting with a good data model is very important. But what is good? What is a good data model? The best way to talk about what is good is showing what is bad. So what I'm going to do today is show you some very simple data. And if we were to make a data model out of this, first we'll do it poorly and why it's bad, and then we'll see how we can change it to make it better. But one of the things you need to think about is what data should be in my model. And by definition, you're going to base it on the data you have. But don't limit yourself to the data you have. Don't just say, I have this table and it has 20 fields on it. I wonder which of these 20 would be good. Better approach is to say, what do I need in the model? Forget about what you have. This is what I need to do good analytics. Now, of these things I need, what do I have? Some of that's sitting in a simple column in a table. You can say, great, that's what I want. Some of it is, I don't directly have it, but if I use this field and call out to this routine and do something else, I can get what I need. So how can you derive what you need based on what you have? Don't just take the raw thing and say, that's my model. That's your transactional model. It's the foundation of your analytic model, but not the end of your analytic model. So find out what you need. How do you know what you need? Chances are you as a builder of it is not the consumer of analytics. The users are the ultimate consumer of this. Find out what they need. One of the things I recommend is go to the customer, the end user, turn off the computer, go to a whiteboard and say, if you could have a dashboard that provided you meaningful information, what would it be on it? That's what they want. Then go backwards from there. Oh, you want this. What would I need to create a model that could provide that? The answer may be some of what they want you don't have. Okay. Maybe there's something you need to keep track of you weren't keeping track of before. That's good, now you know. But you can build a model based on what you have. You can derive new information with some clever coding based on what you have. And your target is to provide them what they need, not to say to the user, we have all this data and all these tables, so we just threw it all into a bunch of cubes here, good luck. And they look at it and say, what do we do with this? It's not necessarily helpful to overwhelm them with all this stuff because, you know, analytics projects that I found the most successful are the ones that have clear targeted goals. For this project, we're going to provide these 5 dashboards, these 10 dashboards, these whatever. And they do these things, and they're very targeted for certain users. And we'll build a data model that supports that, and we'll deliver that. And during that process, someone will say, but this will be a good idea, this will be a good idea. You say, fantastic idea for phase 2. Because if you're not careful, your 7 dashboard project turns into a 50 dashboard project. And you need to, scope creep is really likely in analytics projects. You need to clearly define what you're going to do it, and do more as time goes on. And in the beginning part, the user may not know what they want until you show them some prototypes of things. So it'll be an iterative process. But at some point, you've got to say, this is what we're going to deliver. And over time, we'll add more. And we'll add to the model, and we'll do more things. But it's really important to find out what is really needed. So what you have is a start to determine what is needed. But don't just stop there. Don't just take every field and put it in the model, like we'll do in a few minutes when I show you a bad model. And you don't need all of your existing data. I've got 5 main tables, each of them with 75, 100, say 100 fields. So I've got 500 possible things that could be in the model. Throwing everything into a model and give it to a user is overwhelming them. What's important? Also, different users have different needs. There's not going to be one model that satisfies all these users. In SQL world, there's no one SQL view that is the perfect view that anyone who wants to do any query can just use this one view. No, depending on what you're doing, you need to do different things. There will be different cubes. There will be different parts of the model to satisfy different needs. And you need to know what those are. So don't just throw all your data in. I heard the analogy of, you're going to cook a meal. You don't go to your refrigerator and take everything in the refrigerator. Go to your cabinets and take everything in there, throw it all together and say, here it is. You have a target of what you're trying to do, and you decide which pieces you need. Some of the pieces you need, you don't have. So you go to the store. Some of the pieces you don't need, and data you don't have. But if I write some clever code, I can go get it. So think about the ultimate goal and how you can achieve that goal. Don't just throw everything in and say, here, which we're going to do right now to show you why it's a bad model. And again, this just reiterates what we said. Don't just say, this is what I have, what would make a good model. Say, this is what I need, how can I get it from what I have, or derive it from what I have. So what makes a good model? Again, focus on what is really needed. Several years ago at one of our conferences, we had Alan Cooper wrote a book called The Inmates Are Running the Asylum. It's about the difference between technical people and non-technical people. And one of his quotes is, technical people are generous with their selfishness. And what he means by that is they think they'll need it, so let's throw it in there because somebody probably needs it. So don't confuse might, with what you should include. Oh, someone might need this. It's likely this is needed. It's possible this might not be, so don't overwhelm people with too much information. Also, don't confuse the things someone has to do all day long, multiple times a day, shouldn't be confused with the thing they have to do once a month. And also, you'll have different cubes for different purposes. A very common scenario, many of our customers in the healthcare, let's say you had a cube based on visits. Do you really need a cube that's every visit since time began? I have 20 years worth of visits. Does that, in a database, sure. Does the cube need to have that? For historical research, maybe. So it's perfectly fine to have one cube that is 20 years worth of visits, and another cube that only defines the recent ones. What is recent? That depends on what you're doing. Maybe you have the most recent 6 months, the most recent 2 years, and the people doing what's going on now are using the recent cube. They don't have to go through this huge cube to find out what's going on now. And the people doing historical research have a huger cube. Big deal. That's fine. And I want to update this recent cube constantly. The one that shows historical information, maybe once a day. I don't need to update that every 5 minutes. So different cubes for different purposes, even though we're talking about the same data. I've got information about visits. That doesn't mean I'll only have one cube about visits. There'll be different cubes for different purposes. So in cubes, we have measures. What are we measuring? Typically numeric values, and we can do aggregations, but not all numeric values make a good measure, even though it's a numeric value. Dimensions are how we group things together. We'll see this in a second as we show an example. Patients visit, gender is one of the ways we want to group people. What date did the event occur? In a moment, we're going to show a sales criteria. What product was sold? When was it sold? Where was it sold? How much did we charge? Those types of things. Also, not all string values make good dimensions. And we're going to prove that now. So we're going to look at some very overly simple, for purposes of illustration, data. So we have an order class. We have an order ID. We have the date when the order came in. We have the item, what was ordered. We have a quantity, how many did we order. We have a type, which is a very cryptic name, so even by that title, I don't even know what it is. Per item charge. Okay, so if we take the per item charge and multiply by the quantity, we can probably get how much we get of this. And we have some field called internal, which I don't even know what it means. And then for the product, we have the unique product code, which is the item. The product has a name, and it has a list price. So again, overly simple model just to illustrate the concept. So what happens if we make a cube and we just say every numeric field's a measure and every text field's a dimension? Let's take a look. So maximize this here. So we've got a cube here. By the way, this will be downloadable with the slides as well, so you can look at this. It includes a README file, so if you run setup, I'll populate it with the data you see here. And it doesn't depend on anything else. And all the classes are in a package called ABC. So unless you have your package called ABC, you can pretty much load it in any namespace you have. It won't step on anything. So what do we have here? So we've got order ID, we've got date, we've got item, we've got internal, and we've got type. Okay? Let's look at a couple of things here. So, the item, that's interesting. What do we have here? Well, we've got the item and how many of those we sold. What are they? Sure, internally it has a code, but if I'm doing analysis, I want to know what BK41003 is. So it's much more meaningful analysis if I use a readable value for this and not just take whatever's stored. That would be a better change. But in a moment, we're going to see a different cube that makes some of these changes. So that value is too cryptic. It should be more. I should be able to know what that actual thing is by that. What else do we have here? Internal. Whoever wrote this database many years ago had a field called internal, and the values are 0 and 1. Without any application knowledge, I have no idea what that means. And a value of 0 and 1 is pretty much meaningless for a person doing analysis unless they know what it means. So or if we should even use this field, maybe this field is meaningless and shouldn't even be part of analysis. What else do we have? Remember, dimensions are all about grouping things. How many of this book did we sold? Oh, we sold over 7,704. And how many did we sell by type, whatever type is? Internally, it has some cryptic code, which is too cryptic. I should need to change that. But that means this particular item with whatever type 2 means, this was sold. Pivot tables are all about grouping information. For this product and this type, what did we do? So aggregation is important. But what if I say, okay, so how many things did we order that have this order ID? 1. Order ID is a bad dimension. The whole purpose of it is to group things together. I only have one order with this order ID. This should not be a dimension when we get to the next table. Now, it's very useful if I drill down. Oh, I had 85 at this. I want to drill in. I want to see those 85 orders. I want to see those order IDs. It's useful, but not useful as a dimension. It's too granular. The whole purpose is to group things together. No matter what I do, there's only going to be one order with that order ID. So it's a field, but it's a field it's good for transactional purposes, it's good for drilling, but as a dimension, it's a bad dimension. I can't aggregate on it. There's only one. So you'll see we got rid of that in the next cube. What else do we have here? We've got type we saw, the date. Date. Here's the dates that these things exist. And I'd like to be able to what about the year and I want to be able to group these together, but in this database, date is just a string. It's not a $H date value, it's just a string. But I want to use it as a date because I want to be able to go start with year and then go into month. And so taking the default isn't good enough here and while many of you use dates that have a nice date format, there are applications out there that use dates in different formats. What I need is the system to know it's a date. What I have is a string. Okay, I can turn that string into a date. Now I can use it as a date. So again, don't limit yourself with what you have. Take what you have and get what you need. So we'll change this in the next cube to make this a better date. So we're going to get rid of the order ID. We're going to need a better date. Item is correct. Yeah?
So in this context, order ID is a bad example, but could you think of a scenario where it could be a meaningful dimension, like how many customer complaints you received? I don't know.
Well, in that case, if you had a complaint information, you would have many records complaining about a particular, maybe more product, maybe than order, but that wouldn't be the key to that. If you had I have a complaint class, and every record is a complaint, and I had 24 complaints about an order. Okay, so if that was your basis, if you had a complaint cube, the complaint ID would be a bad dimension. Yeah, so. Yeah, there could be cases where order ID is just a field but not a key in another thing, and you might want to group by them. There could be a case like that. But in this case, it would be. So what are we going to do? We're going to change some of these things. I can zoom back out without getting seasick here. So it's not a good idea to just say every numeric value is a measure and every text is a string. So order ID is too granular. It's fine for listings, it's fine for drilling, but as a way to aggregate information, it's not very, very useful. Remember, the whole purpose of a dimension is to group a series of records based on a common value, and order ID is not good. Also, the names. Go back here. What is date? What date? An order date, a delivery date, a ship date? Names that are too generic are not very useful. In this simple case, I only put one date. What if I had 3 dates? Date by itself is not a good name. A field called name is bad name. Like, what name it? Name of what? This is a count. A count of what? That by default, we give you for free a dimension. We don't know what to call it, so we call it count. But we give you the ability to change it because, this is an order count, which is much more meaningful than count, especially if I have multiple cubes. This is a count of orders. This is a count of visits. This is a count of lab tests. Don't count by itself as too generic. Give things more meaningful names. Also, by default, if you create a cube and you use our architect tool, you can drag the property over and we use it. That's the default. We don't know what else to call it, so we're going to use the name you gave it in the class, which might not be a good name. Type. What's that mean? Well, that's the name it had, and if I don't change it, it's still meaningless. So give things much more meaningful names. It's just the default, because we don't know what else to call it. Think of it as a wizard. Wizards start you off with something, but then you change it to make it more meaningful. Whoever created this field years ago called it type. We don't know what else to call it, so we're going to call it type, but change it to make it more meaningful. We give you something called count because we don't know what you're counting. Change it to make it more meaningful. Also, actually, let's go to the new cube here now. That was cube A. Let's look at cube B. So in cube B, I have order date. That's the name of the dimension. In the source class, I didn't change the original data. In the class, in the source class, it's still called date. But as a dimension, I'm now calling it order date. Product. I like that better than item. I'm giving these names that will make sense for somebody doing analysis. Don't limit yourself to what it's called currently in the source data. Give it meaningful names for the cube. Type happened to be order type. So I gave that a different name. So names are more important. The question is, what name is meaningful? You really should be asking the person who's going to use this. When they see a list of things, if they don't know what it means, it's a bad name. Give it a name that makes sense to them. Also, the members themselves. So let's go back to our example here. Let's go back to the bad one. So item was just a series of product codes. Better, I made product I actually made it a hierarchy. We'll talk about that in a second. But if I say drill into DVDs, I want to see the titles. I don't want to see DVD-8537 whatever. So in the dimension, I made it more meaningful than a cryptic code. Internally, it's still a code that identifies it, but a user wants to see the name. And then I'll talk about hierarchy in a second, but instead of having a list of all the products, I now have the products grouped into books and DVDs, back up, and electronic items. The code still exists, and I decided to make it a tooltip. Oh, by the way, that's EL21. That's useful if I care. But more importantly to most people would be, what's the name of the thing? And you get to decide that when you build the cube. You get to decide what the label is. You get to decide what the tooltip is. So zoom back here. So every dimension has what we call members, the possible values. And every member has a key, the unique identifier that identifies it and makes it different from any other one. And then it has a name, what you actually see. So in this case, the key is the internal product code, and the name is whatever the name is. And it's perfectly fine to have two things with the same name. They can't have the same key. So now, I would also argue that if they do, in your model, you should do something to make the names different, because the user will just see two things with the same name, and you won't know which one is which. You might decide that the name that I'm going to show as a label is the actual name, and then in parentheses, I'm going to put the code. The name could be anything you want it to be. Make your own logic, put it together, concatenate things, completely up to you. In this case, I decided to just show the name and let the tooltip have the code. But I could have had the name be the combination of the name and the code. It's completely up to you. Whatever makes the most sense for the person using this is what you should do. So also, if we go back here, we could remember when we had order type, it was like, now it's retail, online, and no type. The previous one was 1, 0, and null. So it turned out that the type was really how it was sold. And some were retail, so one is 0, and the other we didn't know, so we just 1, 0, and null are meaningless. Give these things meaningful names. Again, I'm not changing anything in the original data. I'm just deciding how the cube will represent that data. Again, notice order date is gone. Also, order date. We'll get back to that in a second when we talk about calculating what is needed. So we have a field that was the actual code. But if you look at that code, actually, I'll just show it to you in the bottom here. It was like EL was electronics, and DVD was DVDs, and BK was books. Although in the original database, it's just a field, logically, I've got a hierarchy here. So I can have a product category. I've got books, I've got DVDs, and I've got electronics. And by the way, these are the products in those categories. So with a little bit of object script and a $piece function, I can figure out even though the source data thinks it's a flat value, logically, it's a hierarchy. And I can allow the person doing analysis to actually take advantage of that. They can say, I now have product, which has both product category, and within product category, I have products. Now, in your database already, you might have a natural hierarchy, or state and city, facility and department within a facility. There's lots of natural hierarchies that exist. And dates is also another natural hierarchy. If you remember our first example, the date was just a string. But I really want to make it a date. I want to be able to come here and say, here are the years, and when I drill into a year, I want to get the months. And when I drill into a month, I want to get the days of those months. That only happens if we know it's a date. So what did we do back here? We basically write what's called a source expression. This is how I pulled apart the product category is the piece before the first dash. Also, notice in this model, we had how much you charge per item, and we had how many you ordered. I have here something called extended price, which is, what did we actually get? I don't want to have to do the multiplication on the fly. For this item, this is the revenue we got. Two different fields, I'm just multiplying together. Again, I didn't have that sitting in a field. All I'm doing is I'm multiplying the quantity times the source. So sometimes what you have is sitting in a simple property. Use it. Sometimes you got to do some logic. That's what a source expression does. How can I get what I want based on what I have? In this case, piece apart the first dash chunk. In this case, do a multiplication. In this case, maybe I've got to find out what this is, call some external function, or call some object script routine somebody wrote 15 years ago that I pass it a value, it gives me an answer. Whatever answer I take, that's what I use. So any existing logic you have can be used to calculate these things. So in this case, I want to skip internal orders. That code it's not only not a dimension, but I only want the orders that are not internal. So in the cube, I said skip those completely. Just because I have a class with 100,000 records doesn't mean I need all of them. I want to build a cube of only active customers. So you can build a cube based on a subset of the rows for a given class. You don't necessarily need all of them. By default, you get all of them. If you say, this is my source, we assume you must want all the rows. Sometimes you don't. I have a database with everybody in the United States, all my customers. I want to build a cube of customers from California. And it can because for this analysis, I don't even need anybody else. I don't want to build one by state and then only use California. I want to make sure only California is in the cube. Both of those are possible. So you can limit what's in the cube. It doesn't have to be every record in the class. That's the default, but you can change it. So again, maybe you only want to do active customers. Maybe you want a queue with only recent visits to the hospital. That can all be set up. There's a special type of dimension in Deep C that deals with time. We need to deal with dates, months, years. The problem we had was, by the way, if you have a $H and you say, yep, that's it. But in this case, we had a string. So all I had to do was use source expression and the good old ZDH function, which has about 82 arguments on it, but that's the one that will get it into proper $H format from an ODBC string. And now we know it's a date, and now we can do things in a date hierarchy. This case I did year, month, and day. You can do decade, you can do quarter, you can do days of week. There's lots of different things. So if we go back here, we come here to the date. Let me just start clean here. I can say, let me see the particular products. Actually, let's do the products category over here. And then I want to do it by date. I could start with year. Then I could drill in and say, well, what happened in 2017? What happened in March? This particular thing happened on the 6th, and so forth. So the hierarchy can exist because, as far as Deep C is concerned, this is now a date. I had to turn it into a $H, but that was pretty straightforward. That's also done at the time the cube is built and updated. So at runtime, this is no different than if you happen to have a property that is a $H. Same thing with the calculation on the price times the quantity. We do that when we build the cube. We're storing that result in the cube. So at runtime, we're just looking at it as if it really existed in the source data. Again, get what you need based on what you have, and sometimes you might have to write a little code to get it in the format that you want. So dates are a good example of a multi-level hierarchy. Again, there are other types of hierarchies that are possible too. Category and product. In the source class, I had one field, but logically, I've got a hierarchy. Country, state, city, region and branch office within a region. There are lots of things you can think of that could be natural hierarchies. A common mistake I see in some cases is people creating hierarchies that aren't hierarchies. I have state, and I have the customers who are in that state. That's not a hierarchy. Customers can move. I might want to query only customers in a state, but their existence as a customer doesn't depend on the fact that they're in a state. Cities within a state, that's a hierarchy. Within this state, I have different cities. But don't create hierarchies that aren't natural hierarchies. Also, there are times where I have to do a calculation. There's a session after this in this room called Can It Be Measured? And it talks about all the different ways you can create measures in deep sea. One of the ways you can do is what's called a calculated measure. So this is an MDX, not cache object script. And if I use this, let's go back and make a new one here. I can say, okay, for this product, I want to find out what the revenue is and the percent of total. So, okay, books represent 23.1% and DVDs represent, so that's something that I don't get from each record. That's on the fly. I've got to look at what the context is and figure out that percentage. It also, for example, that's overall. What if I say, yeah, but I'm particularly interested in, I want to filter now. What about those that happened last year? Now, on the fly, this percentage is adjusted for those particular set of records. Because think about it. What is a particular cell? This, by definition, is whatever my row is, whatever my column is, and whatever my filter is, that represents a set of records. And for that set of records, this represents the price. You know, if I wanted to find out how many units, you know, this cell and this cell and this cell represent the same set of records. And that is books in 2016. 3 different things about those books, but different measures about the same set of records. Because MDX is all about aggregating data, aggregating sets. And of course, once I have a set of records, I can say, show me the, whoops, if I do that, I made a mistake in the listing. I can drill into the details if I correct my listing error there. Sorry about that. Now you know it's a real demo. And let's go back to the slides. So MDX can be used to make calculated dimensions, which are not based on one value, but based on a set of values and how to calculate them. Notice this expression, although it's a simple MDX expression, is an MDX expression, not an object strip expression with a format. The session after this talks a lot about different measures. Talks about standard measures, calculated measures, something called plugins, which I'll just mention briefly here. This is a case where, and again, Jessica will get a lot of details here. This cell represents a set of data. This cell represents books in 2016. If I want to be more specific, I can say it represents books. Let me put an order type here. Okay, let's start with here. This cell represents DVDs sold via the retail channel in 2016. And that number is Deep Sea saying, oh, you define this as a sum. We do lots of bitmap indices. We're going to quickly sum them all together and say, here's your answer. We can do that for you very fast. But what if you want to do your own logic? What if you say, for that given set of records, I want to take complete control. I want to calculate it myself. We provide an API that Jessica will get into about, here's the set of records. Loop through them, do whatever you want, and whatever number you give us back, we'll use. So you have the ability to do stuff that we can do for you, or you have the ability to say, so if this value were a plugin, for this set of records, we're going to run your logic and return a number. For this set of records, which is a different set of records, we're going to do the same thing. So you have complete control over how a measure is calculated. Most of the time, we can do it for you. We'll do average, max, sum, all the standard things. But there are times where you say, my calculation is so custom, just tell me the records and I'll do it myself, and you can do that. And Jessica will get into more details in the next session in this room after this. So plugins are very powerful. I think of it as the ultimate custom measure. Just tell me the records and I'll do the calculation myself. Let's go back to the next slide. So order B is a better cube because order ID is not a dimension. It's too granular. Fine for a listing, but not for a dimension. Dimensions should have better names. They should have meaningful names. If you look at it and you don't know what it is, it's a bad name. By the way, let me rephrase that. If the end user looks at it and doesn't know what it is, it's a bad name. Doesn't matter what you think. They're the ones using it. Also, the items themselves, the members. You know, cryptic codes, 10 null. What does that mean? What is BK852? So give these things the members meaningful names. There are hierarchies that are in the data. The date we saw, but also in this case, that product value really was logically a hierarchy with a category and a product. In this case, internal orders was a flag. We don't need them. Build restriction is an option on a cube where you can say, but I don't want these certain things, or I only want these things. So I only want customers from California in the cube. The cube doesn't have to be every row in the source. Date was a string. I want a deep C to treat it as a date, so I used a source expression to turn it into $H. Pretty straightforward. Extended price, the quantity times the unit cost. Do that. Percent of total, an MDX example to calculate something. If I look at my source data, there's nothing there that says anything about percent of total, but percent of total is important, so we added it. The plugin example, I never actually showed a query on that. Let me show that. If I said we've got books that were sold in, let's say the current year. So I'm going to bring over the year ordered, and I can pick a year, or I can pick now. That's handy, because next year it'll mean 2018. It adapts to whatever the current year is, instead of picking a hard-coded one. So those are the things that happen there. And I want to know what I sold, and I want to know what the extended price is, which is basically the quantity times that. And I also want to know the current value. The second one is a plugin. What the second one is saying is, go for this set of records, look at the product that was ordered, and call some external logic that says, what's this cost now? So if I sold that right now, how much would it be? That's something that isn't in the database. I would have to go out and get some external logic. Maybe I have to call a web service. Maybe I have to call some API that's some stock information. You can go out to external data, do what you need to do, and make that part of a measure as well. Jessica looked at a lot of details of exactly how to do a plugin in her session after this session. So there's a value based on the data, and here's a value based on some custom logic that I did. Again, calculated member using a plugin. One other thing I want to talk about briefly as we're getting close to the end of the time here is sometimes I want to use the entire cube, but sometimes I want to present a particular user with a logical subset of that cube. Not a different cube, but he should only see certain things. So if I come over here and start new, orders B has 89,000, if I can zoom in there, 887 records in it. The source class has 100,000, but I'm skipping the internal orders. So this is everything in QB. And notice I've got the order count. Notice I changed the name. Count was too generic. Order count's a much better name. I've got units sold. I've got extended price, which is a very accounting-like term. What does that mean? I've got the order date. I've got the product. I've got the order type. Well, what if I take a look now at this thing called orders online? Orders online is only 62,567 records. I have the date, I have the product, and that's all I have. Orders online is a subject area. Think of it like an SQL view. An SQL view isn't physically a separate table, but it's a logical subset of the table. So this, I've limited here to only see the online orders. And by the way, since I'm only seeing the online orders, having a field that tells me what type of order it is kind of redundant because they're all the same type. So I decided to hide the order type. I don't need it here. Also, this thing called extended price, I think it's much more meaningful if I call this revenue. So I can say, oh, what's the revenue for this product? By the way, I haven't changed the name of the dimension, of the measure. Because if I look at the MDX that this runs, the thing is still called extended price. What a subject area allows you to do is filter information. So it's like an implicit filter. When I use this subject area, it automatically filters only to what I need. And it hides certain things. So in this case, I'm hiding the type. Also, I can change the name. Extended price for this particular subject area is called revenue. So if you have a different user, this person thinks of it as a department and this person thinks of it as something else, you can give them a subject area that logically changes the name that they see, but doesn't actually change the internal name, so it ends up running the same queries. So subject areas are a way to provide a filtered subset, not only of the rows, but of the columns, you want to think of it that way. And all these things have resources and privileges. So here's a big cube that I only allow this person to see. The person who's in charge of sales in the West Coast can see California and these states, and the person who's in charge of the East Coast sees different states. They're looking at the same cube, but they're looking at a logical subset of the cube. So through security, you can control who can see what. This person should never see the revenue information. So for that subject area, you hide the revenue column. So that allows you to create these logical subsets and control it by user of what to do. So to summarize, a good data model really is the foundation. If you don't have a good foundation, how do you, I mean, someone once said, if you're building a house, you can't lay the foundation until you know what type of house you're building. If you're building a data model, what will people do with the data? That really depends on how you build the data model. And again, just to reiterate earlier, find out what you need in the model to do the analytics that you need to do, and based on that, figure out how to get it from what you have. In many cases, it'll be very easy. It's in this field, it's in this field, it's in this field. In other cases, a little piece function or changing it. In some other cases, I need to call out to this object script function that somebody wrote 10 years ago, and that gives me the advance I want. So get what you need based on what you have. Don't let what you have limit what you can do. The data you have is a start, but not an end. So you can always derive what you really, and how do you find out what you need? You need to talk to the user, you need to find out the type of information that's meaningful. So that's the general end. There is a survey for the session that's part of the conference app. The Tech Exchange is still going till noon today. In this room, starting at 11, is a session called How Can It Be Measured, which is a session on much more details on all the different types of measures that can exist, showing several examples of that Jessica will be doing. And I have a little bit of time for questions. And if anyone wants to ask a question, if you could please go to the microphone in the center here, because we are recording the session. So whoever, by all the sessions, if there's a session you couldn't attend that you want to find out about, post-conference, the slides will be posted as well as the recording. So anybody have any particular data modeling or other questions? Well, we have a little bit of time. Also, I'm around. I'm going to be sitting in the Jessica's session. If you're interested in the details on measures, I'd encourage you to stay for that session. The Tech Exchange actually is closing at noon, but I'm around. You know how to find me. Joe@intersystems.com works. There are other ones too, but the easiest one to remember is that one. And if you don't have any other questions, thank you for your time.